Hi students, good afternoon everyone. Today we are going to discuss about the topic that is friction. Okay, let us discuss the topic that is friction. So what is friction is first to understand the friction. Let us first I will explain with you a small by taking a small example. Let us see. Suppose say this is a body. Suppose say this is a body when a capital F is the applied force, suppose say I have applied a force F, then what will happen? Suppose if a body, suppose a F force is applied and I have left, after applying force I have left it, then what will happen? After some time the body will move like this and somewhere it will come and it will stop here, it will stop. When I have pushed it with the force here, then if I leave it, then what will happen? The body will move like this and it will stop up to here. So it is stopping here. That means what will happen? As the bodies move from here to here, its velocity keep on decreasing. Its velocity is decreasing. That means a retarding takes place. Retarding means what? Retarding is deceleration, means acceleration is decreasing, means its velocity keep on decreasing. Why this decrement of acceleration takes place? In opposite direction, opposing force is said to be active. According to the Newton's second law, as we know that F is equals to ma. This is the formula. So here, whatever I have applied a force, the body is moving in this direction with, suppose say this is a mass m, which is this one. M, the body is moving with an acceleration a, so m into a is nothing but applied force, m into a. So here, this acceleration is nothing but this one decreasing in acceleration. So when the acceleration is decreasing, that means it is going on, it is moving with a slow and finally it stops. Why it happens means because in opposite direction, one frictional force is said to be acting. That frictional force is nothing but it is applied by the ground. That means ground is another surface which is below this one. It may be ground or table, whatever may be. This surface will try to stop this body. That means in opposite direction, a frictional force is said to be acting. This frictional force is responsible for this body to come into rest. Why it is rest means quickly it is coming to the rest means because of this frictional force. Okay, so here one thing is to be keep in mind that always the frictional force will be always in the opposite direction to that of the applied force. Suppose I have applied a force in this direction, that means in opposite direction the frictional force will be acting. So that is called frictional force. So frictional force is nothing but it is an opposing force which comes into play between the two bodies when they are in contact. So that is called frictional force. Okay, so here suppose say this is one body, this is one more body. Suppose I have taken two bodies. So when the frictional force will come into play means when the molecules of one body, the molecules on the outer surface of one body and the molecules of a surface of another body, if they are in contact with each other, then a force of attraction takes place between those two molecules. Molecules of this body and the molecules of this body, when they are kept in contact, then what happens is they both attract each other. That means one contact force is said to be acting between those two molecules. So say that suppose say I am just applied a small force such that the body is not moving. Okay, so when I have applied a small force such that in this direction, such that the body is not moving, during that time, the molecules of this surface and the molecules of this surface, they are at this surface, they will interact with each other. Means they are getting attracting with each other. So during that time, a force is said to be acting. That is called contact force. So between these two, a contact force is said to be acting. That contact force will be acting in this direction. So this is called contact force. So this is called contact force. Here, contact force can be split up into two components. One will be in this direction and one will be in this direction. This is called normal force and this is called frictional force. So here frictional force is nothing but it is the one of the component of contact force. Contact force means what? These two are in contact. These two are in contact with the molecules of this surface, the molecules of this surface, these two are kept attracted. So that attractive force is this one. This is called contact force. So this contact force can be split up into two components. One is in vertically like this, that is normal force, and one is in this direction, that is frictional force. So here normal force is nothing but equal to the weight of this body. Suppose this weight is say in downward direction, suppose its weight is mg. This normal reaction in this direction, say this is n. Therefore, n is equals to mg is called normal force. This is nothing but normal force. Okay, so these two will get balanced. Why? Because the body is not moving down or neither it is moving up. So normal force is balanced with the weight of the body. But whereas the frictional force will act in such a way that always it will be opposite to that of the applied force. So this is called frictional force. So let us define how to define the frictional force here. So frictional force is nothing but when a body moves or tends to move, then a force between these two bodies comes into play such that the force will be acting in a parallel to that surface and it will be always opposite to the relative motion between them. That means if the two bodies are there, if the body is moving or about to move during that time, what will happen? The force will be acting in the direction that is parallel to that of the surfaces, these two surfaces, and this frictional force will be always how it is acting opposite to the motion of a body. Suppose the body is trying to move that side, but this will oppose in opposite direction. So this is called friction. Okay, this is said to be a friction. Once again, I repeat, what is friction means? Friction is nothing but when a body moves or tends to move, then a force is said to be acting between the two bodies such that the force will be acting in a opposite to the opposite direction to that of the motion of a body. So it will play such a role that between these two it will come. This force will act between the surface of two bodies which are in contact, and it will be always tries to stop the motion of the body. So this frictional force always tries to stop the relative motion between these two bodies. So this is called frictional force. Here frictional force. Here frictional force depends upon what factor means. Suppose say this is the body of mass m, as I told you. Suppose this is the applied force here. Then in this direction are said to be a frictional force. This is called frictional force. Here, therefore, here, you suppose this is a body, the normal reaction will be acting in upward direction, say this is m, and in the downward direction, its weight that is mg. So here, normal reaction is equals to mg. These two are balanced. Then, what is frictional force here? Frictional force is always directly proportional to the normal reaction. Keep in mind that how much normal reaction is there, that much of friction is there. Friction between the two surfaces depends upon the normal reaction. Normal reaction is what? Its weight only. Normal reaction is its weight only. So frictional force depends upon the weight of a body. If the weight is more, then it will feel difficult to move in a forward direction. That means that much of frictional force will be acting. So here frictional force is directly proportional to normal reaction. So I can say here P is proportional to, I can write mg. Or first I will write that to remove this proportionality, we have to equate some constant. Say that the constant is mu. Yes. Mu means this is called constant into n. Therefore, F. Suppose say this body is in static. Static means what? Rest. So I will say it as the Fs. Static friction I will take. Suppose is equals to mu s into, this is called mg. So here frictional force formula, general formula, Fs is equals to mu s into mg. Here mu s is called Fs by mg. This is called coefficient of friction. So here friction is nothing but is equals to mu s into mg. Here mu s is called coefficient of static friction, or I can say coefficient of static friction. This is a constant value. This is a constant value for a given bodies. For a given body in a contact, this value will be constant. Okay. So this is called coefficient of static friction. So what is coefficient of static friction? How to define this? Coefficient of static friction can be defined as it is the ratio of frictional force to that of the, this is called what? Normal reaction. This is called normal reaction. So we can define this one. Suppose definition of mu s. How to define this one? We can say it is the ratio of frictional force to its normal reaction. So this is the definition of mu s. Mu s is nothing but it is the ratio of frictional force to that of its normal reaction. So this is the definition for a coefficient of static friction. So this is called regarding frictional force we are talking. So here frictional force is of three types are there. One is static friction, and one is kinetic friction, and one is rolling friction. There are three types are there. So in that one we have studied already. This is called static friction. So here we can say that frictional force types of friction. One is static. The second one is kinetic. Third one is rolling. So frictional force is of three types are there. One is static friction, one is kinetic friction, one is rolling friction. So static friction is nothing but if the two bodies are in contact such that the body is not moving. Suppose I have applied a force, still it is not moving. Then the friction acting between these two bodies is called, such a friction is called static friction. So that is the case here. See, I have, this is not static friction is nothing but this one only. See, I have taken a body of mass m where I have applied a force F, because of which the body is supposed not moving. The body is not moving means in opposite direction a frictional force is said to be acting which opposes the motion of the body. So here in this case if you see now the body is in equilibrium state. That means whatever I have applied the force that is equals to frictional force only. That much of force is developed here. And here normal reaction is nothing but is equals to mg, its weight at an equilibrium position. So here I can say at equilibrium position I got n is equals to mg, and here one more thing, frictional force between the two bodies is nothing but is directly proportional to n, that is normal reaction. If the weight of the body is increasing, that means if you take a bigger body of more weight, then it will have more friction. That means the friction is directly proportional to n. Therefore, F is equal to mu s into n. Here mu s is nothing but is called constant. Therefore, what is this constant? This constant is called coefficient of static friction. So this is called coefficient of static friction. So this can be defined as how to define the coefficient of static friction? It is nothing but the ratio of frictional force to that of the normal reaction. So this is how we can say the static friction. So this is comes under when the body is not now moving, then we can say this one. Okay, suppose say Suppose, as I have applied a force here, then static friction is said to be acting. This is called static friction. If I apply furthermore, then what happened? Now, suppose say a body just start to move. Now the body is just about to move. During that time, the maximum static friction is said to be acting. That maximum static friction can be written as Fs max, or which is also called it as a limiting friction. So here I can say that this is the force I have applied for which the body is not at all moving. Initially I told you that is called static friction. Now suppose still I am applying the more force. Now the body is just about to slide. Still the body is not moving, but it is ready to slide. If I apply more than this, then the body will start moving. So during that situation, what are the frictional forces acting? That frictional force is called maximum static friction, or it is also called limiting friction. That limiting friction also, like we have a same formula. That means in generally I can say that static friction, if you talk in generally, static friction will be always less than, is directly proportional to, as I told you, normal reaction, and is directly proportional to mu s into n means what here? N means what here? Normal reaction. That is n is equals to mg. So I can write here mg. So here static friction I can write. If I remove this one, I have to equal some constant. Sorry, I have already equated. To remove this proportionality constant, I have to write some equal. Okay, so instead of that equal, what I am going to write is I will write less than or equal to that of the n. And one constant, I have to write one constant, mu s into n. Why I have written this one like this means, here this less than is nothing but that means the friction will be less than or equal to normal reaction. So here I will tell you, Fs is less than or equal to mu s into n is what? Mg. Here from this, Fs is less than, suppose, mu s into mg. And one more, Fs is equals to mu s into mg. So from this we are getting two conditions. That is, one is frictional force is less than mu s into mg, and second thing is mu s is equal to mu s, Fs is equal to mu s into mg. What is these two? This is the situation when the body is not moving. That means, suppose say I have taken a body, just I have applied some force, then the body is not moving, then I can use this one. Still I am applying, but still the body is not at all moving. Still applying, still the body is not at all moving. Then I will apply this formula. That means frictional force is still less than that of the mu s into mg. Frictional force is less still. If suppose, if I have applied a certain force, for which the body just about to slide. If I apply beyond this, then the body will slide. So during that situation, whatever the force is acting, that is called what? Maximum static friction. Now, maximum static friction developed in this. Okay, that friction is then during that we have to use this one. That is, this one I will tell it as a maximum static friction. So for a maximum static friction is equal to mu s into mg, we have to write. For normally static friction, that is for which the body not at all moving, still furthermore force is required. For this, I will use this formula. So this is so by combining these two, I can write this formula. We can use this. Okay. So here, this is called maximum static friction. Now, if you see beyond this maximum static friction, if I apply further more, then what will happen? The body will start moving in a forward direction. During that time, what will have is that is called kinetic friction. That is called kinetic friction. So for kinetic friction, also we can say like this one in the similar manner. So I will rub this and again I will tell for that also. Kinetic friction. As I told you just now, if you apply a force here, mass m, its normal reaction in this direction, and in downward direction its weight, then in opposite direction, a frictional force is said to be acting. In case this one, this is kinetic friction. Kinetic means I will write F into Fk, F of suffix k. So this is called kinetic friction. The kinetic friction is nothing but it is the opposing force which comes into play between the two bodies when one body is moving on the other body. Okay, the frictional force which comes into play between the two bodies when one body moves on another body. So here in this case, the body is said to be moving in forward direction. So during this time, what are the frictional forces acting between two bodies? That is called frictional force. Here also, frictional force, that is kinetic frictional force, also again directly proportional to the normal reaction, that is N. Therefore, Fk is equals to, here some constant is to be written. The constant here I will tell mu into k into N. N is what here? Here since N is nothing but mg. So N is mg. So this is called kinetic friction. So from this mu k is equals to, we can write Fk by mg. What is here mu k? Mu k is nothing but is called coefficient of kinetic friction. So when the body is moving on one another, then the coefficient of kinetic friction will be given by this one. That is nothing but it is the ratio of kinetic friction to that of the normal reaction. This is called normal reaction. This is normal reaction. So this is called kinetic friction to that of the normal reaction will give what? Coefficient of kinetic friction. Similarly, if the suppose a body is rolling, this is regarding kinetic. Now I am talking about a body suppose rolling. Suppose a body is rolling. Suppose a body is rolling in this case. Suppose a body is rolling. Then what are the friction acting at this point? Here also a rolling friction, I will say Fr. Here Fr is called rolling friction. Here also is directly proportional to normal reaction. That is, this is normal reaction. This is its weight mg. Therefore, also here one more law is there. Also it depends upon the radius also. Suppose its radius is suppose say small r. Suppose small r is called radius. Then here frictional force is inversely proportional to its radius. Sometimes generally we use this formula only. Sometimes for the calculation purpose. Sometimes they rare. In case if they ask regarding, if they ask in a problem, if they ask related by giving a radius, what is the frictional force if they ask for a rolling, then we have to take this formula also. Say from these two I can say Fr is proportional to N, also I can take it as R. By combining these two I can write like this. So therefore Fr I can say that is equals to some constant, say that is mu r. Into I can write N by R also. So this is the, and here I can say, here what is here? Fr is equals to mu s by R. Here N is nothing but, what is this? mg. So here mg. Since N is equals to, I can write mg. So this is called frictional force. So rolling frictional force can be is equals to mu s to mg by R also we can see. Okay. So therefore Let us see the graphical representation between applied force and frictional force. As I told you, if suppose this is a body, suppose I have applied a force F, capital F is called applied force. In this direction, what are the forces acting? This is called frictional force. So here I will take applied force, that is capital F, and in this direction, and in this direction I will take what? Frictional force. In this case, if you see, when F is equals to 0, during that time, this also set to be 0. Both are equal. If this is 0, this is also 0. That means initially both are at this point. So I can applied force is 0, this is also 0, so this is 0 at origin. Therefore, as this is increasing, suppose here, as it is increasing, this frictional force in opposite direction also keep on increasing. How long it will increase? Until it will just about to slide. That means if I am applying, if I apply this external force, then that much of frictional force also develop. That means these two are directly proportional. So applied force is increasing, means frictional force also increase. So both are increasing linearly up to certain point. That means up to this applied force, up to this much of applied force, the maximum frictional force is said to be developed. This is called, I will tell this as a Fs max, I will tell, or it is also called FL. This is called Fs max or FL. FL means what? Limiting friction or maximum static friction. So up to this it will be linear. Means maximum force when I have applied, so that much of maximum frictional force is developed. Beyond this force, if I apply, now the body will start moving in this direction. During that time, what will happen? This maximum friction will be not there. During that time, the frictional force is said to be a kinetic friction. Here the kinetic friction will be, now the kinetic friction during the motion, it will be reduces. That means the friction will be less than that of the maximum static friction. Why? Because when the body is not moving, that time maximum static friction. When a force is applied further, now the body starts moving. So during this time, its friction reduces. Because of that, it is moving. So that means here the kinetic friction will be less than that of the maximum static friction. Maximum static friction. That means at this point, this is the maximum static friction. Thereafter, as the further I have applied force is further increasing, its frictional force will be decreasing. So it will decrease in this direction. So in this way, it will decrease. Thereafter, now the body is moving continuously. During that time, a kinetic force also acting continuously. So that means the kinetic friction will be in this way, like this. So as the applied force is acting, the kinetic friction at that time will be constant. So decreases. So this is called Fk. This peak value is called Fs maximum. From here to here, this is called Fs, means static friction. This length is called static friction. This point is called maximum static friction. Thereafter it came down. This is called kinetic friction. So this somewhere it will be like this. So this point is called kinetic friction. This point is called maximum static friction. And every point between this maximum and 0, every point will be called static friction. So this is the graphical representation between applied force as well as frictional force. Okay, so this is the graphical representation we can see. Now, let us see some laws of friction. There are some laws of frictions are there. Means there are some laws are there for a friction. What is that? The first law we can say the friction between the any two bodies, that is the friction is directly proportional to the normal reaction. That means how much weight is there, that much of friction is said to be acting. Just now we have discussed that also. That is the first point. That is called first point. I will make you to write it. Therefore, what is the second point? The second point is the friction depends upon the nature of the body, nature of surface of a body, and also roughness of that surface. That means what nature it is, means what, whether it is made up of wood or whether it is made up of any iron. So which what is the nature of that surface, as well as the nature is whether it is polished one or whether it is rough one. So it depends upon these two factors. That means the friction depends on the nature of the surface as well as the roughness of a surface. That is the second point. Next, third point is, now the third point. Third point is, frictional force does not depends upon the area of contact between the two surfaces. That means, if suppose the same body, suppose this is the body, I have kept like this. How much frictional force is there? Means F is directly proportional to its weight. And the same body, if I keep like this, now in this time it has occupied more area. It has occupied more area. Okay, but if I place this one like this, now it has occupied less area. Don't think that now this is occupying less area, so less frictional force, more area, more frictional force. It's not like that. Just frictional force depends upon its weight. That is normal reaction. Okay, it is independent of its area of contact. Okay, so that is the third point. And let us see what is fourth point. Fourth point is Fourth point, we can say that the velocity, the kinetic, fourth point is the kinetic friction between the two bodies. When a body is moving during that time, the kinetic friction between the two bodies is independent of the relative motion between the two bodies. Means with how much it's moving faster, it does not depend. That means kinetic friction between the two bodies is independent of the relative velocity of the two bodies. Whether they may go faster or they may go slow, whatever it may be, it is independent. That is, friction is independent of the relative velocity. So this is the one more point. Okay. So I will write this. First one is so frictional force is directly proportional to the normal reaction, that is N is equal to mg. Next one. So here, second point is frictional force depends on the nature of friction, nature of surface of a body, and roughness of surface of a body. So it depends upon the nature of surface and roughness of the surface. So this third one. Frictional force is independent of area of contact. It does not depend upon the area of contact. So these are the laws of friction. So these are the 4 points. Keep in mind this one. Clear? Our next topic is angle of friction. Say I am representing with the letter, say this is phi. Let us see what is angle of friction. Angle of friction means what? Suppose say this is a body of mass m. Suppose say here I have applied a force F. That means I have applied a force F such that the body is just about to move. Means what? At that time, a maximum static friction is said to be acting in this direction. Means in opposite direction, a maximum static friction is said to be acting, which is called limiting friction. Beyond this, if you apply more force, then what will happen to the body? The body starts moving. That is, a kinetic friction is said to be acting. Okay, so just before the kinetic friction, a maximum static friction is said to be acting between these two bodies. So that situation I am considering here. Okay, in this situation, this is called a maximum static friction, and in this direction, we know that a normal reaction is said to be acting, which is nothing but equal to mg. Okay, so here, suppose that this is the applied force. So here, the angle, say this is called, say I am telling it as R. What is here R? R is nothing but this is called, it is the resultant of normal reaction and the maximum static force. So the resultant of these two forces, one more force is called, that is called, say this is resultant force. So this resultant force is making an angle phi with the normal reaction. This angle is called angle of friction. So angle of friction is nothing but it can be defined as it is the angle made by the resultant of normal reaction and the maximum static force with the normal reaction. So this is called definition of a angle of friction. Okay, let us define. I will write the definition. Definition of angle of friction. It is the angle made by the resultant of normal reaction. It is the angle made by the resultant of normal reaction and maximum static friction with the normal reaction. See here, what I am telling is here, it is the angle made by the resultant of normal reaction and the maximum static friction. So normal reaction and maximum static friction resultant is this one. With whom? With the normal reaction. With the normal reaction, that is this angle. This angle is called angle of friction. This is the definition. Okay, this is the definition of angle of friction. So therefore, here, so let us see here some concept we will see. Here from this, it is quite clear that if I take this diagram separately, in this direction a normal reaction is there. In this direction a maximum static friction is there. The resultant of these two is in this direction. Say this is, I am telling it as a R. Okay, so here if I draw one line like this, if I draw a perpendicular line, then if I draw a perpendicular line, if this is N means this is also N only. This is the angle we have taken. So I will take this one. If this is static, maximum static friction means if I draw this like this is also maximum static friction only. So from this triangle, if I take tan theta is equals to, what is tan theta here? Tan theta means what here? Tan theta is nothing but I can say this by this. This is perpendicular by this base. What is perpendicular? This perpendicular is nothing but this is maximum static friction. That is Fs max divided by. This is what this is. This is nothing but this is called normal reaction N. So I can say this as a normal reaction N. Okay. Since we know that here N is equals to mu s into mg. Sorry. Since N is equal to mg, and we know that these two are equal. So if I substitute here, what is mu s into max? This we can write as mu s into normal reaction. And here also one more normal reaction. So both are equal only, which is nothing but equals to mg. So therefore these two will get cancelled. Therefore we can say that tan phi is equals to, we can say mu s. So this is the relation between angle of friction and coefficient of static friction. So if suppose some angle is given, suppose if they have given angle of friction, if they ask what is the coefficient of friction between the two surfaces, means we can, by substituting this value, we can calculate the coefficient of static friction. Suppose they have given the angle, they may ask this, or by giving this value, they may ask this also. So in this way, this is the important formula while solving a problem. Okay. Then also, here from this triangle, this is called resultant R. This is R resultant, this one. This is the resultant. So from the triangle, I can say that also here R square is equals to, this is called Fs max and this is called normal. So this is nothing but this triangle is called, I can apply from the right angle triangle, a Pythagoras apply. Pythagoras formula if I apply, then R square is equals to Fs max whole square plus n square. Therefore, R is equals to root of Fs max whole square plus n square. Therefore, root of Fs max means what? Just now Fs max means mu s into n. So mu s into n whole square plus again this one n square. Here thereafter R is equals to, we can write root of, this can be written as mu square n square plus n square. From here n square, if it is coming out of this root, then it will become n. So I can keep outside. Therefore n is equal to n into root of mu square plus 1. So this is the reaction. Resultant of these two is given by, this is the formula. What is N is here? N is nothing but N root of mu square plus 1. So these two formulas, from these two formulas, we can solve any problem. While solving the problem, if they may ask to calculate the resultant of normal reaction and maximum static friction, the resultant of these two is given by this one. What is the magnitude of this? How much this one is? To calculate the magnitude of this value, we can use this formula. R is equals to mg root of mu square plus 1. So this gives the magnitude of this resultant force, and this will give the direction of this resultant force with the normal reaction. So with the normal reaction, at what angle it is. So it will give, in one way we can say that direction also we can say. So this angle represents the direction of this resultant with respect to a normal reaction also. How much angle with this. So in this way we can calculate these values. Now next is angle of repose. What is angle of repose here? What is angle of repose? Angle of repose means, first I will draw a diagram and then I will explain you. Suppose this is an inclined surface such that it is making an angle, say this is theta with the horizontal. Okay, now suppose I have placed one body at this point. I have placed one body of mass m, of say mass m I have placed. So here, when the body is kept, suppose when a body is placed at this point, suppose a body is placed on it, if I lift this body, what will happen? This body will start move. So the point at which the body on the surface is just about to move, that angle is called angle of repose. So here, angle of repose is nothing but it is the angle made by the inclined surface with the horizontal, at which the body on the inclined surface just about to slide. That angle is called angle of repose. Again I repeat, the angle made by the inclined surface with the horizontal, at which the body on the inclined surface just about to slide, just ready to slide. That means it is not sliding, just about to slide. So during that time, the body is about to slide in this direction. That means in opposite direction, a maximum static friction is said to be acting. Why? Because this is the situation that just about to slide. So in this case, a maximum static friction is said to be acting. So during this time, this angle is said to be an angle of repose. This is called angle of repose. So here, I will define here. Define angle of repose. How to define this? The angle made by the inclined surface with the horizontal, the angle made by the inclined surface with the horizontal, at which the body on the inclined surface is just about to slide. or I can say here the minimum angle, or I can say the minimum angle, or I can say the minimum angle made by the inclined surface. Means if I do maximum, it will start moving. So that I have to make a minimum angle for which the body is just about to slide. So this is the definition. The minimum angle made by the inclined surface with the horizontal at which the body is just about to slide. This angle is called angle of repose. This is called angle of repose. So let us see here some concept here. Suppose this is a body of mass m. So its weight is acting in downward direction, say that is mg. Now this mg can be split up into two components from the geometry. If this is one, this if I have drawn like this, and one more this one. That means this can be split up into two rectangular components, such that from the geometry, if this is angle theta, this is also angle theta. Why? Because if you see, if this inclination is making down, that means if this inclination is making down, this angle will become 0. If this is becoming 0, at that time, this normal what we have drawn, that will also come in this direction. So if you are doing this one down, means if this inclination is making an angle 0, means this one, this line also will come in down, means it will also come in this direction. So this angle both are equal. So if this is m, that means the angle which is made, this is called mg cos theta, and another one, this is called mg sin theta. And this body normal reaction will be in this direction, say that is n. So now at see, now the body is not at all moving. That means the body is just about to slide. Now it is not moving. So during this situation, I can say that it is in equilibrium condition. That means on the body there are four forces are said to be acting. In upward direction, that is called frictional force. And in this direction, one force is acting, that is mg sin theta. That means these two will get balanced. These two are said to be balanced. Okay, these two are said to be balanced. Why? Because the body is not moving anyway. Similarly, these two already we know that the normal reaction is equals to this one, that is in this direction, this component, that is mg cos theta. So at equilibrium, I can say maximum static friction is equals to, what is that? That is in opposite to that, mg sin theta. Say this as equation 1. And one more, normal reaction is equals to mg cos theta. Say this as equation 2. So now if I divide these two equations, equation 1 divided by equation 2, if I do, then Fs max divided by n is equals to this side, mg sin theta by mg cos theta. So these two will get cancelled. So therefore, here what is this formula? This is nothing but minus into normal reaction n. This is n. This is equals to sin by cos is called tan theta. So these two will get cancelled. Again, we are getting minus is equals to tan theta. So here, as we have seen previously, mu(s) is equals to, we got tan of phi previously, that is called angle of friction. Mu(s) is equals to tan of angle of friction we got. And in this case, mu(s) is equals to tan of angle of repose we are getting. That means from these two equations, it is quite clear that angle of repose and angle of friction both are equal. That means angle of friction is equals to angle of repose, we can say. Okay, since I will write that also. Since we got mu s is equals to tan of phi. Therefore, from these two equations, we can say that theta or phi is equals to theta. That means angle of friction is equals to angle of repose. So angle of friction is equals to, we can say that angle of repose. So this is the relation. That means these two are equal. So fine. So remaining whatever the topic is there, that we will discuss in a tomorrow session. Okay. Till then, bye.